Now, in this video, we'll be looking at very simple problems on solving logarithm-related expressions. The instructions here is simplify each of the following logarithmic expressions, giving the final answer as a single logarithm. Now, if you want to have a quick refresh on the various rules or laws of logarithm, you can check out for the video on that. I created a video on that. Now, if you have a full grasp of the various laws of logarithm, now let's just start with these very simple problems on how to use logarithmic rules. Now, the very first question we have here is the logarithm of 4 to base 2 plus the logarithm of 0.5 to base 2. How do we simplify this? We can use the first rule, which is the product rule. Okay? From here, we will see that we could rewrite this as the logarithm of 4 multiplied by 0.5 to base 2. We could write this like this. And 4 multiplied by 0.5 is going to give us what? It's going to give us 2. So logarithm of 2 to base 2 is obviously going to give us 1. This is one way to do it. Okay? Another person could have gone through another approach of rewriting this as logarithm of 4 can be written as 2 to the power of 2 to base 2 plus 0.5 is the same as 1 over 2 or 2 raised to power minus 1. Okay, so we could rewrite 0.5 as logarithm of 2 to the power of minus 1 to base 2. Okay, then we take 2 to the power using the power law, and we have 2 logarithm of 2 to base 2 plus, then we take this minus to the back, minus 1 to the back, it becomes minus 1 logarithm of 2 to base 2. And we have learned that the logarithm of a number to the same base is going to give us what? 1. So meaning that this is technically 2 times 1, and this is 1 minus 1 times 1. So we have 2 minus 1, which will still give us what? 1. So whichever approach you follow, still see we are getting the same answer. All right, now let's look at the second one. The second one, we have logarithm of 10 to base 2 minus logarithm of 5 to base 2. Okay, this can also be written as what? The logarithm of 10 divided by 5. That's the quotient rule to base 2. And this becomes what? 10 divided by 5 is 2. So we have logarithm of 2 to base 2, which is also give us 1. Okay, the third one, of course, there are also multiple approach you can follow, depending on the one that comes to your head first. Here, somebody could say, I could take this index back to as a power, this 2 as a power, that we have logarithm of 4 to the power of 2 base 2 plus logarithm of 8 to the base of 2. So 4 to the power of 2 is 16. So we could say this is logarithm of 16 multiplied by 8 to the base of 2. And this gives you what? Logarithm. So if you multiply 16 by 8, what do we have? 16 by 8, that's the same as 8 by 8 times 2. That's 64 by 2. That's 128. So we have logarithm of 128 to the base of 2. So logarithm of 128 to the base of 2, we could rewrite 128 as logarithm of 2 to the power of 7 base 2. And this will give you 7 log 2 base 2, which is the same as what? Which is the same as 7. Okay? Another approach is, instead of going through this approach, if we observe closely, we will see that we could just rewrite 4. I think that's the much more simpler approach. If we could just write 4 as 2 to the power of 2, so that we have, let's just bring the solution down here. We have 2 logarithm of 2 to the power of 2 base 2 plus logarithm of 8 can be written as 2 to the power of 3 base 2, right? Then these 2 can come to the back here so that we have 2 times 2. We now have 4 logarithm of 2 to the power of 2 plus this 3 can also come to the back and become 3 logarithm of 2 to the base of 2. Then log 2 base 2 is 1, log 2 base 2 is 1. So we have 4 plus 3, which will also give us what? 7. So whichever approach we follow, we still see that we get the same result. We get the same result. So these are very, very simple problems on logarithm. So in the subsequent videos, we'll see much more. I've decided to do the videos by levels of complexity of the problem. So this is a very easy, just applying the very basic law of logarithm. So you can check out some of my other videos where we solve much more challenging problem or thought-provoking problems on logarithm.